Alright guys, this is the last video that you're going to need to watch for Wednesday, which is September 24th. And you're supposed to take notes on it. Your sub's going to check them, and then I'm going to see what your work was on the worksheet that you'll get in class tomorrow, and I'll check that next Monday. So this video is number 3, and it's on properties and types of functions. So properties of functions meaning what is true about functions, and then types of functions meaning different sort of manifestations, different versions of functions that we may see going forward. So the agenda for this video is going to be, we're going to go over the relative maximums and minimums. In short, that means the highest or lowest point in a given region of a function. We're going to go over even and odd functions and their symmetries. And finally, we're going to review what piecewise functions look like and how to solve problems with them. So the first one was relative max and min. A relative maximum. F of a is a relative max of f if f of a is greater than f of x for all x in the interval. So you're going to want to write down that definition. And it looks like a lot of math mumbo-jumbo, but really all it's saying is that everything is lower than the relative maximum in a certain interval. So the in a certain interval is important because that says that it's a relative maximum as opposed to a universal maximum. So it's not going to be the highest point in the whole graph, it's just going to be the highest point in that region. You'll see what that looks like when we get to a graph. And the relative minimum is the opposite. F of b is the relative minimum of f if f of b is less than f of x for all x in the interval. So we're going to look at two graphs of them. The black one is relative maximum, and this graph actually has two relative maximums. And the way that we're going to review what those are is that they're the dotted lines. The dotted lines go through the graph because those are the two highest points. And the dot right at the top of the graph right there is going to be the higher of the two relative maximums. But they're both relative maximums. So there we have a relative maximum right here and right here. And the relative maximum is going to be referred to as with these coordinates, a and f of a, because that's what we had in our definition. We have f of a is the y coordinate, that is the relative maximum, so that's the highest point. And then a, just a, is basically, we're saying where it occurs. It occurs at a, or at the, and a is our x coordinate. So this point right here is the x coordinate a. So x equals a. Alright? Alright, now moving forward. So those are both relative maximums, and they're relative because they're only the maximum on the interval between those two green points. So this one right here is the relative maximum between those 2 points, and this one would be the relative maximum between these 2 points. So it just means that it's the highest, you peak for a second in the graph. And then going on to relative minimums, so this is an example of a relative minimum. There actually is only one relative minimum in this one, and that's because we don't change the direction of the graph except for another point. Except for this one point right here. Alright? Because in every other situation, so if we start here and go this way, we're going up the entire time. So everything is greater than that. And then if I go this way, we're still going up the entire time. So everything is greater than that. And we never get to a point where we stop and come back up and then down. If we did, then we would have a situation like we did over here, in which case there would be a second relative minimum. But in this case, we've just got the one. And that occurs at b f of b. So it's the same way that this occurred at a f of a, is that this one occurs at b f of b. So the relative minimum is f of b, and it occurs at point b. So x equals b. Alright, so those are relative minimums and relative maximums. And again, this is only true on a certain interval, but in this case, the interval happens to have the whole graph in it. So that's all we have to know about relative minimums and relative maximums. Now we're going to move on to even and odd functions. Even functions are true for f of negative x equals f of x. And then odd functions are the reverse for that last term. There's a negative here now. So we've got that f of negative x equals negative f of x. Now I'm going to go through an example. An example of an even function is x squared, in which case you'll have a parabola. That's what it looks like, and it's symmetric about the origin, or sorry, symmetric about the y-axis. And when you have a negative x and a positive x, their values are both listed right here, and they're the same. They're going to be x squared. So the negative version of x and the positive version of x both spit out the same term. And then for an odd function, you could have something like x cubed, and you're going to have that the negative function spits out the negative version of the positive one. So we've got negative x and positive x, and their function outputs are x cubed and negative x cubed. And remember, if you do the math, negative x cubed becomes negative x cubed without the parentheses, because you don't get rid of a negative in a cubic. Alright, so one thing that I want to point out is that it kind of makes sense that they're called even and odd, because this is going to be true for all even exponents, and this will be true for all odd exponents, if that's the only term. If you have a bunch of other stuff here, then it screws it up. Alright? So now the one symmetry that I want to mention is that the even ones are symmetric about the y-axis. So that means if I folded it onto itself, then it would fold evenly about the y-axis. Every point flipped over the y-axis would be a point on the other side. Whereas in an odd function, you've got is going to be symmetric about the origin. So if I start at the origin and move to a certain point, it's going to be the same distance in the exact opposite direction to another point on the graph. So those are the same distance, except they're in the opposite direction. Alright? So the first one is symmetric about the y-axis, the second one is symmetric about the origin. So that's all you need to know about even and odd functions. The last thing I want to mention is the cell phone plan example, which is going to show what piecewise functions are. So the problem at hand is that we've got a cell phone plan that's $20 a month for 60 minutes, and then we have 40 cents a minute thereafter. So after we spend after we already do 60 minutes, we have to spend more money in order to get more minutes onto the plan. So we're going to express this as a single function, C of t, which is cost per month, that t is for time elapsed. And the first thing that we need to do is set up which function acts which way, and what the interval they act in is. So in this case, we've got when t is between 0 and 60, in other words, when the number of minutes is between 0 minutes and 60 minutes, so when this is between 0 and 60, we're going to have just $20 a month. And remember, we're evaluating this in cost per month. So the only thing that we need to write down there is going to be $20 per month. And now the other term we have is going to be after those 60 minutes. So when t is greater than 60 minutes, we have to have another kind of function. And that function is going to look like this. So it looks a little bit complicated. I'm going to break it down for you really quick. The 20 comes from here. That's the $20 we spent in the first month. The 0.04 is, actually that's a typo. That should be 0.40. That's my fault. So that should be 0.40. That's the amount that we spend after. It's 0.40 per t minus 60. And the t minus 60 is because it's after. So every time after the original 60 minutes. So we're only going to be charging for the minutes that happened after the original 60 minutes. So say I have something for 70 minutes. I'm not charging 70 minutes worth of 40 cents. I'm only charging the 10 that happened after the original 60. So if I looked at that on a number line, it would look like through here, this is all $20, and then after it, every step is going to be another 40 cents each. Okay? So now we want to try to figure out how we can use this piecewise function to solve problems. So let's look at two examples, C of 30 and C of 100. C of 30 is actually really easy. Since 20 is between 0 and 60, that means that this is going to satisfy this condition between 0 and 60. So the answer is just 20. Now the next one that we have, I'm going to need to make some changes here because of the 0.04. But the next one we have, all we need to do is plug in 100 for t. So 100 goes in for t right here. And then after we plug that in and do the math, we'll end up getting 0.40. We'll end up getting that the plan will be the same thing as 20 plus 0.4 times 40, which is going to be the same as 20 plus 16. So our final plan would be $36 for the month. Okay? So those are the only types of questions that you'll have to worry about for the rest of Chapter 1, Section 3. Just to review quickly what we did. We went through even and odd functions, we went through piecewise functions, and we went through relative max and min. The relative max and min, you just saw graphs about what they look like. The relative max is the highest point in a certain region, and the relative min is the lowest point in a certain region. Even and odd functions, there's different kind of symmetries that you need to be aware of for them. Even functions are symmetric about the y-axis. Odd functions are symmetric about the origin, and you're going to need to know their definitions. And then finally, cell phone plan example. This is for piecewise functions. You use the latter part of those terms, the part that I'm about to circle in green, this part, to figure out what the parameters are, and then you use this part to figure out what your functions will look like right here. Okay, and that's it. All right. So you're going to have a worksheet to do in class that I expect you guys to complete for Monday, and notes on this video should be completed for class so that you can check. The secret word for this one to make sure that you watched the video is going to be black hole. Alright? Thank you.